this is how to find the secant line containing 2 points that are on the graph of a given function. So first thing I want to mention is that we can visualize this real quick. So if I open up Desmos and I feed it this h of x, and I can find the point, okay, let's see, x equals 7. Real quick, that is over here. So I have the point 7, 14. There we go. There's that point. And now I need to figure out where the point for 8 is. That's right there. So it's 824. Here's 824. What I'm doing is I'm finding the slope of a line that connects this blue dot and this green dot. Let me make this bold so it's a little more easy to see. There we go. So I'm finding the equation of a line that passes through those 2 points. Right? So this is how we would sort of visualize what we're doing. We're cutting across these 2 points. Okay, so let's actually do it now. Or let's do this algebraically. I should point out that you do not need the graph in order to do this. I think it just helps to visualize, and it can also check to see if your answer is right at the very end. Okay, so the first thing I want to do is actually figure out what these points are. So remember that h of 7, what that really means is everywhere I used to see an x over here, I now need to replace it by 7. So this would be 7 squared minus 5 times 7. That's going to be 49 minus 35. And that gives me 14. Okay, better yet, let me stack this vertically instead of horizontally so you can see the steps one by one. All right, and I'm going to repeat the same process for h of 8. What this means is everywhere I used to see an x, it should now be an 8. So this is going to be 8 squared minus 5 times 8. Or in other words, it's going to be 64 minus 40. Or in other words, that's going to be 24. So in other words, this point right here is really the point 7, 14. And this point right here is really the point 8, 24. This checks out because this is what we saw on the graphing calculator. Over here, this graph, 824, that's the second point. Here it is. We found these on the calculator as well. So this confirms what we were doing. Okay, and just to make the association a little more clear, this is really this. And this guy right here, we'll use purple, is really this. Okay, so the next thing I need to do is I need to come up with the slope, because remember, to make a line, you need either 2 points or you need a slope and a point. We have 2 points, so we need to find the slope. So the slope of my line, we're going to call it M. I'm going to go ahead and set my font back to black. I need to plug in my y1, y2, my x1, my x2. Now, it doesn't matter which one you consider which, so I'm just going to choose to make this red point my first point. So I'm going to say difference in y's. So I have 14 minus 24. My difference in x's, it doesn't matter which one you decide comes first, but you have to be consistent. And I find this color coding kind of helps with that, because then I know my points are kind of stacked up like this, where this is one point and this is the other point. Okay, and now I just subtract. So I have 14 minus 24, that's negative 10. 7 minus 8 is negative 1. The negative on the top and bottom cancels to leave me with just 10. So in other words, the slope of the line that connects these two things, that would be 10. But now I'm not done yet, because if I just do y equals 10x, very clearly we can see that this new line doesn't actually pass through these points. It kind of needs to be moved over a little bit. So what I need to do is use either the purple point or the red point, or in your case, whatever points you have. I need to use these to come up with either the intercept, or you can use point slope form. So I'm going to show you 2 different ways to do this. I'm going to insert a table and we'll do 2 methods. Method 1, it depends on how Pearson wants you to put this in. So I would say use slope intercept form. So I know y equals mx plus b for slope-intercept form, but we just found out that our m should be 10. So the only thing I'm missing now is this b value. Remember, this b value is supposed to be the y-intercept, but I don't know it. I do, though. I do know my x and my y. I have either choice. I can choose either this red point or I can choose this purple point. It doesn't matter. You're going to get the same answer either way. Just to prove it, I'm going to do another little table where I do this two different ways. So I'm going to have one over here. I'm going to use the red point. So I'm going to say I plug in 7, and I'm supposed to get out 14. So let's see what b is going to be. So now I'm going to have 70 plus b. Now I subtract 70 from both sides, and this gives me, oh man, what is that? Negative 56. Just going to double check that. Yeah, negative 56. Ooh. So this one tells me my line should be y equals 10x minus 56. All right, let's try it with the other point and see if we get the same thing. I'm supposed to get out 24 when I plug in 8. Okay. So this is going to end up being 80. Now I need to subtract 80 from both sides to get b by itself. And when I do that, I'm going to double check 80 minus 24. That gives me, once again, negative 56. So this side also tells me that y should be 10x minus 56. I'm just proving that it doesn't matter which point you use, you still get the same line. Method 2 is arguably a little bit easier. Use the point slope form. The reason we like point slope form is that it tells you your line pretty much right away. You need to choose either point, doesn't matter, again, red or purple. I think you get the idea that it doesn't matter, you still get the same answer when you simplify. So I'm just going to choose the red. It does not matter, I will get the same line if I choose purple as well. Point slope form is y minus y1 equals mx minus x1, where your x1 and y1, that represents a coordinate that is on, or a point that is on the line. And we have 2 points that are on the line for sure, so we can just plug in either one, it doesn't matter. I know that my m is supposed to be 10, we found that earlier. I know my y1 is supposed to be 14, and my x1 is supposed to be 7. So this line right here is equivalent to this line, and it's of course equivalent to this line as well. One way that you can prove to yourself that these things are the same line is by simplifying this and turning it into slope-intercept. The way that you would do that is just distribute the 10 here, so this would give me 70. And then I would add 14 to both sides. Plus 14 here. But when I do negative 70 plus 14, that's going to end up giving me my negative 56. So as you can see, I end up getting exactly the same line either way. Right? It's the same line here, it's the same line here. And finally, let's double check using Desmos. If I graph the line 10x minus 56, sure enough, it cuts right through those 2 points. The line is pretty steep, so what I'm going to do real quick is just change the x scale. So I'm going to say my step size is 0.1. That fix it? Actually, I'm going to do, yeah, my x-axis should go from like 6.5 to like 8.1. Yeah, so all I did was I changed the scale a little bit so you can see how the line cuts through that. The red is the original function, and now you can see that the secant line cuts right through those 2 points. Okay, so this is how you find the equation of a secant line using 2 points that are on the graph of a function.